Let's go with all of the question. Question 1. Which of the statement below not related with alkanes? Alkanes are hydrocarbons which have a general formula of CnH2n. This is correct, even though it's not the correct way for alkene. So alkane has CnH2n plus 2, but it's still CnH2n, so it is correct. Alkane are the simplest and least reactive class of organic compound. Alkane contain linear and branch chain of carbon atom. This is incorrect because only here. Alkane contains linear, branch, and also cyclic. All bonds of alkane contain only single bond. This is correct, so the answer is C. So butane has a higher boiling temperature than 2-methylpropane. This is because definitely butane, which is a straight chain, has a larger surface area. So because of the larger surface area, the London dispersion force is stronger, which make the boiling temperature to be higher. So the following liquid all have the same number of electrons in each molecule. Which one is likely to have the lowest boiling point? So the lowest boiling point will be the molecule with the highest number of branching. So in the first option, you have an alcohol. Definitely alcohol will have the highest boiling point in this case because of the hydrogen bonding. So now we have 3 alkanes, which is fine with the highest branching. So that will be B. So the structural formula of 3-ethylheptane, so in this case we just need to count the number of carbon in a straight chain. So in a straight chain must be heptane, that means you have 7 carbon. So A, we have 7 carbon as well, and at the third carbon, which is here 1, 2, 3, at the third carbon we have an ethyl substituent, therefore A is the answer. The mechanism of the reaction represented by the equation given is an example of free radical substitution reaction. So remember, for any alkane must undergo substitution. It cannot undergo any other type of reaction. The next question, which of these is likely to be the best solvent for gasoline? So gasoline is a non-polar compound. That means it will be the most soluble in a non-polar compound. So in this case, it must be donkey. So which sort of species form when a bond breaks homolytically? Any homolytic fusion, they will form a free radicals. So in the molecule of propene, C3H6, how many sigma and how many pi bonds? So let's just draw the structure. So we have a propene, and all single bond will be sigma. So we have 1, 2, 3, 4, 5, 6, 7, and the double bond is composed of 1 sigma. So we have 8 sigma and we have 1 pi bond. So the answer is D. The role of pi bond in addition reaction of hexane is definitely as a nucleophile. So what is the IUPAC name for the following compound? So just count the number of carbon first. So 1, 2, 3, 4, 5. So we have pent2 in. Since the methyl group is on a different position between the C double bond C, that means this is the E, which means the opposite side, therefore E, pent2 in. So what are the suitable reagents for the reaction below? So this is a change of alkene into alkane. So definitely you need to add hydrogen. And then you need a catalyst here, and for this reaction the catalyst will be nickel. So the answer is A. The next one, the relativity high boiling point of butanol in relation to their intermolecular forces is the result of, so because of the OH it can form hydrogen bonding. So the answer is donkey. So which of the following is the correct order for the process used to obtain petrol from crude oil? So first, the petroleum need to undergo fractional distillation, and after that it can undergo cracking to change it into a smaller molecule, and then we can reform them to reduce the knocking. Then you have your petrol. So the answer is donkey. So refluxing chlorobutane in aqueous potassium hydroxide solution will produce butanol as the organic product. In this case, hydroxide ion plays a role as a nucleophile. Let's go into section B. The first question, butane C4H10 is a hydrocarbon which is used as fuel. So explain what is meant by the term saturated hydrocarbon. here we just need to memorize the definition, which saturated hydrocarbon are hydrocarbon that contains only single bond in between their atoms and has a maximum number of hydrogen attached to the carbon. So write an equation with state symbol for the complete combustion of butane. So C for H10 combustion, that means in the presence of oxygen it will produce carbon dioxide and also water, and since it required state symbol, so C for H10 is a gas, and here you have a gas as well as oxygen. Carbon dioxide is also a gas and water is a liquid, so just balance up. So we need 4 carbon on the right hand side, and then we need 5 hydrogen on the right hand side, and the balance for oxygen have 15/2 for oxygen. So octane can be cracked in the presence of catalysts to produce pentane and propene. Find the term cracking. Cracking is a decomposition that involves the breaking of carbon-carbon bond into smaller molecule. Again, this is just a definition which need to be memorized, and write an equation for this reaction. 8 H18, it will be cracked. So state 2 reasons why cracking is important. Cracking, it is used to increase the quality and also quantity of more desirable product, which is mostly petrol, and to decrease the amount of residual, which is a high number of hydrocarbon. Let's get into the question 2. The following compound are the example of organic compound. Name of each of the compound. So let's go into A. For easier representation, let's draw. So I'm going to draw the skeletal formula of the compound. 1, 2, 3, 4, 5, 6. And then at carbon number 2 we have an OH here, and at carbon number 5 we have 2 chain. So since we have an OH, we need to start counting from the right. So we have 1, 2, 3, 4, 5, 6. And at carbon number 5 we have 2 substituent, which is a methyl substituent. So start with that. So we have 5,5-dimethyl, and then we have hexane 2-ol, where the 2 representing where the OH is situated at. Let's go into B. So we have 4 carbon. So 1, 2, 3, 4, and at carbon number 2 we have a double bond O. At carbon number 3 we have 2 substituent. So start counting from the right to give the double bond O the lowest number possible. So 1, 2, 3, 4. And at carbon number 3 we have 2 substituent. So start with that. So we have 3,3-dimethyl. And then this is a ketone, therefore but or butan 2-on. Into compound C. So here we have 4. At the first carbon we have 2 substituent, 1 and 2. And then we have a double bond here. We also have a substituent Cl here. So we can start counting from the right to give the double bond the lowest number possible, because this is a more prominent or the dominant structure. So we have 1, 2, 3, 4, 5. So at carbon number 2 we have 1 substituent, and at carbon number 4 we have 1 substituent. So alphabetically ordered, so that means we start with Cl. So 4 chloro, and then 2 methyl, and then we have pen or pentan 2 in. Let's go into compound D. 1, 2, 3, 4, 5, and then we have C double bond O, OH. Next, carbon number 4 we have an ethyl substituent. So we must start counting from the right, because the C double bond O, OH will always be the first carbon. So we have 1, 2, 3, 4, 5. However, if you go to the top, so instead of number 5 here, if you go to the top you will have 5 and 6. So the longest chain here is actually 6, and then at carbon number 4 we have a substituent. So start with that. So we have 4-methyl hexanoic acid. Let's get to the next question. Liquefied petroleum gas is a fuel sold as an alternative to petrol. It is a mixture of liquefied C3 and C4 alkanes. So suggest a reason why the alkanes are liquefied. So the reason why the alkane are liquefied because vapor will easily catch fire. So vapor will cause an explosion. However, liquid hydrocarbon are much safer to transport because it will not catch fire that easily. The answer here because to make it safer to be transported or less risk for it to become combustible. So there are 2 isomers of butane. Draw the skeletal formula of each of the butane species provided. Give the IUPAC name of each of the compound. Finally, we have a straight chain butane first. So we have 1, 2, 3, and 4. And this is the butane. And another one, we have 3 carbon in the structure with 1 substituent at the second carbon. So here we have 2-methyl propane. Move on the next question. Question 3. Explain what is meant by the term homolytic fission, heterolytic fission, and substitution reaction. Homolytic fission as an equal sharing of electron in the bond when the bond breaks, and heterolytic fission is an unequal sharing of electron in the bond when the bond breaks. While substitution reaction is a reaction in which an atom or a group of atoms is replaced by another atom or a group of atoms. So B, what reagent and condition will be used to make chloroethane from ethane? If you want to produce halogenoalkane from alkane, definitely the reagent required here is chlorine gas, and the condition you must be in the presence of UV light. So state the type of reaction by which this reaction occurs. So this is your free radical substitution reaction. So state in full mechanism for this reaction to make chloroethane from ethane. Then we start with initiation process where the Cl2 in the presence of UV light will undergo homolytic fission, so it will form a chlorine radical. And in propagation step, the chlorine radical will attack the ethane to produce hydrogen chloride and also ethane radical. And the ethane radical will then attack another chlorine molecule to form the compound. And another chlorine radical. So this reaction will continue until in termination step, where the possibility is all of the radicals will collide with one another. For example, the chlorine radical will collide another with chlorine radical to form chlorine molecule, or we have ethane radical colliding with a chlorine radical to form chloroethane, or we have ethane radical colliding with another ethane radical to form butane. The next question, question 4. Treatment of 2-methyl-butene with hydrogen chloride yields 2 products in an unequal amount. Name the reaction taking place. So a reaction of alkene with hydrogen chloride is definitely what we call electrophilic addition. So draw the display formula of each of these products and give the appropriate name for both products. When you react with hydrogen chloride, it will yield 2 products according to stability of carbocation and also due to Markovnikov rule. So the major product would be 2-chloro, 2-methylbutene, following the Markovnikov rule and also stability of carbocation. And we have the minor product, which the Cl will be here, and this is anti-stability of carbocation and also anti-Markovnikov rule. So draw a stepwise mechanism for the reaction of 2-methylbutene with hydrogen chloride, which form the major product. So we have here, this is your 2-methyl, reacting with hydrogen chloride. The first step is the double bond will attack the H, which make the HCl to undergo heterolytic fission, which it will form a carbocation. Now the chloride ion is the new nucleophile, so it will attack the carbocation to produce the product. So explain why the major product is formed in terms of stability carbocation, because here the tertiary carbocation is more stable due to the positive inductive effect by the 3-alkyl group. So last question, substitution reaction of halogenoalkane can proceed via SN1 and SN2, each having its own mechanism. So 2-chloro-2-methylpropane react with aqueous potassium hydroxide to yield the product A. So draw the displaced formula and give the IUPAC name of product A. Halogenoalkane will react with aqueous alkali to produce an alcohol. This is the initial reactant. So when react with KOH, it will produce a tertiary alcohol. So since it want a displayed formula, so all of the bonds need to be shown. So we open up all of the bonds. So we have OH here. So describe with the aid of curly arrow the movement of the electron in the mechanism for the product A. Practically, this question asks for mechanism. And since 2-chloro-2-methylpropane is a tertiary halogenoalkane, it will react via SN1. So we start with the reactant. So 2-chloro-2-methylpropane. So at first it will undergo heterolytic fission, where both of the electron in the bond will go to chlorine. So it will form a tertiary carbocation. Then the tertiary carbocation will be attacked by the hydroxide ion, which is the nucleophile, which it will form the product. The next one, 2-chloro-2-methylpropane then react with ethanolic potassium hydroxide to yield the major isomeric product of B, identify product B. Halogenoalkane will react with alcoholic alkali. It will undergo elimination reaction where it will produce an alkene. So the double bond could fall here or it could fall here. But anyhow, where the double bond is situated at, whether at the left hand side or at the right hand side, it will yield the same product. Product is 2-methyl, prop 1 in.